Welcome back, Focus Learners. Today on our Explainer, we're diving straight into a seriously groundbreaking paper by Howie Hu and their incredible team. It's called Anticipate and Learn: Unleashing Idle Time Compute in Proactive Agents. And look, we're going to see how this research is trying to totally transform AI. We're talking about moving away from an AI that just, waits around for your commands and stepping into this whole new era where your AI actually anticipates what you need next. So, let's just get right into it.
I want you to really think about this for a second. What is your AI doing right now? Like, right this very second? Unless you're literally hitting enter on a prompt, the answer is absolutely nothing. It's just sitting there, completely idle. It's waiting. And according to the researchers behind today's paper, that idle time, well, that represents a massive, glaring missed opportunity in how we're currently using all that incredible computing power.
Which brings us to Section 1. The reactive AI problem and wasted idle time. Let's look at this fundamental flaw.
To really grasp the problem here, we've got to define what we're actually working with right now. The researchers call our current models reactive agents. And what this means is that despite all these wild capabilities they have in reasoning and using tools, they're fundamentally reactive. They only compute responses after getting an explicit prompt from you. Honestly, it's kind of like having a highly capable but incredibly lazy assistant. They only do work when you directly ask them to. The rest of the time, that critical idle time between your interactions is just totally wasted. They're staring at the wall, completely ignoring this huge opportunity to prepare for what you might need next.
So we're looking at a major paradigm shift here. On one side, we have our current reality, reactive agents that just wait for prompts and totally ignore that precious idle time. But on the flip side, we have this new vision from the researchers, proactive agents. These are systems built to actually anticipate your needs and leverage that idle time of compute. The whole goal is to move entirely away from this reactive waiting game and instead build a system that uses its downtime to get ready for your very next move.
So how do we make that leap? That's Section 2, Unleashing Idle Time Compute, a completely new AI paradigm. Enter the real hero of our explainer today, ProAct. ProAct is a brand new proactive agent architecture, and its entire purpose is to leverage that idle time compute to anticipate and fulfill what you're likely going to ask for next. Imagine if that assistant we talked about didn't just sit there blankly, but actually organized your desk and pulled up the relevant files before you even walked into the room. That's exactly what ProAct is designed to do.
Now, the really cool part is exactly how it pulls off this anticipation. ProAct continuously analyzes your evolving dialogue history, and it pairs that with a persistent memory to predict your next query. It's not magic, right? It's just highly contextual analysis. It's looking at the conversation you're having right now, combining it with what it already has stored in its memory, and using all of that to accurately foresee exactly what information you're probably going to need next.
Let's look a little deeper at Section 3, how ProAct anticipates needs and the background mechanics making it happen. So while you're just sitting there reading a previous response, ProAct is actually in the background rapidly executing these 3 specific steps. Step 1, it predicts your upcoming needs based on all that context we just mentioned. Step 2, it iteratively acquires information, meaning it's actively searching and gathering data related to what it thinks you'll ask. And Step 3, it resolves any knowledge gaps and prepares the actual evidence. It's doing all this heavy lifting before you've even typed a single word of your next query.
But a theoretical architecture is just a theory until we test it. That brings us to Section 4, testing with ProActEval and the rigorous evaluation process.
To truly put these proactive capabilities to the test, the team built a massive, comprehensive new benchmark called ProActEval. And the scope of this thing is wild. They tested Proactive against 200 comprehensive scenarios across 40 totally diverse domains. They tested it on predictable need chains, basically checking if the AI can follow a logical, multi-step thought progression. They even accounted for diverse user cognitive profiles. So this establishes a really rigorous scientific backing. They didn't just run a couple of simple prompts, they put this thing through a massive, complex gauntlet.
And all that rigorous testing leads us to the payoff. Let's get into the hard data in Section 5, the impressive empirical results, comparing ProAct to the baseline.
Okay, here is the first major win, and it's a big one. The empirical data shows that ProAct speeds up task completion by slashing the required conversational turns by 14.8%. Because the AI has already anticipated what you want and actually prepared the evidence, you just don't have to go back and forth nearly as much. The whole interaction becomes instantly streamlined.
And right on the heels of that is our second massive win.
user effort drops by 11.7%. Think about what that means for you. That is real time, energy, and cognitive load saved on your end. When your AI uses its downtime to grab information in advance, you are literally doing less work to get the answers you need. It's a total game changer.
But honestly, this next finding, this is absolutely the ultimate win of the whole paper. We're looking at a massive 28.1% drop in hallucination rates compared to the baseline. No way, right? But it makes sense, because ProAct uses its idle time to actively resolve knowledge gaps and prepare evidence before it has to answer you. It isn't panicking to generate a response from scratch the second you hit enter. It actually has the time to get its facts straight, which leads to way more accurate outputs.
And just to add to that, the researchers didn't stop at ProActEval. They also ran MemBench evaluations, which confirmed that ProAct achieves state-of-the-art reflective accuracy. Basically, it's incredibly good at looking back at past memories to make the right choices today. And this is crucial because it proves ProAct's performance is highly robust and sustained. Its ability to reflect and anticipate doesn't just fade away, it stays razor-sharp over time.
Let's bring all this together as we wrap up with Section 6, the future of agents, moving into a proactive era.
We're looking at a massive paradigm shift here, moving from reactive chatbots to deeply proactive agents. So I want to leave you with this final provocative thought to take away from today's explainer. If your AI is no longer just waiting around for a prompt, if it's actively using its idle time to analyze dialogue, resolve gaps, and constantly prepare for your very next move, what will you be able to achieve next? I mean, the ceiling for productivity just got pushed way, way up. Thank you so much for joining the Focused Learners. Keep exploring, keep questioning, and I'll see you next time.